Let's continue our discussion with some important properties of the binomial distribution. The first property is, of course, the mean. Mean is also denoted as expectation of x, where x is the random variable following the binomial distribution, which is also denoted as mu, and this is np. Next is the variance. Variance is also denoted as the expectation of x minus mu whole square. This is also called sigma square, and the formula for this is npq. Remember, the p is the probability of success and q is that of the failure. Then some less important properties: coefficient of skewness, which is also denoted as alpha 3. The formula of alpha 3 is q minus p by root over of npq. Fourth one is coefficient of Kurtosis, also denoted as alpha 4. The formula for this is 3 plus 1 minus 6pq by npq. Fifth property is the moment generating function of binomial distribution, which is also denoted by mxt. The formula for this is q plus p to the power t whole to the power n. Sixth property, the characteristic function of binomial distribution. This is very easy, just replace t by I omega. So phi x omega equals to q plus p to the power I omega whole to the power n. So I have already said that among these properties, these two, the mean and variance, are very important. You have to use this formula again and again, and you must remember this. Properties 3 and 4, they are not so much important. You can remember it, but if you cannot, it's no problem. The fifth one, moment generating function, is also important, and if you remember this, you can also remember the characteristics function. Just replace t with I omega. Now, the next very important thing to understand is the law of large number in case of Bernoulli trials. We have already seen the law of large number in general, but how does it turns out in case of Bernoulli trials? So let's assume that the random variable is x, which of course denotes the number of success in n Bernoulli trials, and we also know that x follows binomial distribution. The value x by n is the proportion of success. Now see this, the expectation of x is np. We have seen it earlier, and from the properties of expectation of x by n is equals to p. So if you write down the law of large number, so limit n tends to infinity, probability of x by n minus p mod of this greater than equals to epsilon is equals to 0, and epsilon can be a positive number as much as possible, as much small as possible. Now pause for a moment and think about it. Just understand what this formula is saying. I'll write down it. As n, the number of Bernoulli trials, goes to infinity, that means n becomes very large, then the proportion of success, which is x by n, goes very close to as close as possible to p, which is the probability of success in one Bernoulli trial. I request you again to pause for a moment and understand this by your heart and soul. This is very important.